Hello everyone and welcome back to another video. Now again on the tablet. I have made the same video in like a real life way with showing the card in hand, and I don't think it really worked out, so I'm doing it on the tablet here because we are going to look at the PCB of the GTX 780 Ti GHz edition from Gigabyte. This PCB is identical to the 780 Ti Windforce OC card, and it should also be mostly, if not completely identical to the 780 GHz edition and also Windforce. There is a version that uses the reference PCB, not this one, but for the one that uses the custom one, the PCB should be pretty much the same. So, specifically right here we have the 780 Ti GHz edition. So this is pretty much the highest end version of this card, though the lower end ones, technically lower end ones, use the same PCB. This one is just meant to come with a higher stock overclock and a better binned core, which, well, my Windforce was better than this until it died and came back and lost 80 MHz on the core. Now this one is better, but this card is also dead. Specifically, these two memory modules need to be replaced because they both create memory errors in mats. So yeah, the card doesn't currently work. I need to figure out how to replace those memory modules, and then I can run it. But this doesn't stop us from looking at the PCB. So yeah, let's start with the most important thing, which is our Vcore Vrm, which we have right here. Now this is an 8-phase controlled by an NCP4208. So that's an 8-phase controller from On Semiconductor. The reference PCB is using a 4206, which is mostly the same, but as a 6-phase. So this is an 8-phase controller. You see this a lot, actually. Like Palette used this on their Jetstream cards as well in a very similar VRM, and so is Gigabyte. So yeah, it's a pretty typical 8-phase controller. You can get some custom voltage control on it in software. On this card, you just have to switch MS Afterburner into extended MSI mode, and then you get up to 1.3 volts voltage control, which translates into about 1.25 behind the core because there's voltage loss over the power plane, but at the VRM you're actually getting 1.3 volts. On other cards, for example my 780 Jetstream, which has the same controller, I had to do some modifications to the MS Afterburner profile, like the file in MS Afterburner that it reads, for that to work. But on this card specifically, it just worked out of the box. So yeah. So I've already said we're driving an 8-phase Vcore Vrm, and this is where it kind of gets a bit disappointing because the RMOSes we are using here, so the reference card and also the before mentioned Palette Jetstream cards all use FDMF 6823Cs, which are 50 amp DRMOSes. They are pretty decent. It's just that the reference card only has 6 of them, which for a 780 or 780 Ti is not enough. And then you get 8 of them on some other custom PCBs. On this one you don't get these. On this PCB you get Renesa's R2J 2065 8 BNPs. And these are 40 amp DRMOSes. So we're losing 10 amps per phase compared to the Jetstream cards from Palette. This is still better than reference, where you get 6 times 50 amps. Here you have 8 times 40 amps, but that's just 240 amps total. That's not a lot. And also, like, these DRMOSes are not really the newest ones. They're pretty old. Like, the datasheet says it's dated September 30th, 2011. Those are, well, 10 years, not entirely, like almost 10 years old now. And 40 amp DRMOSes back then were nowhere near as efficient as they are today. And even today, 40 amp power stages and DRMOSes are not really as efficient as like 60, 70, 90 amp power stages. So this VRM is not very efficient. I can't tell how efficient exactly because I don't know how to do those calculations. It's just like the lower current capable your DRMOS power stage is, usually the less efficient it is. And I can confirm that this VRM runs very, very hot. Like the PCB gets very, very hot with the card under load. So yeah, these DRMOSs are not really that great. It's still better than reference, and it will probably do overclocking just fine. It will just run a bit hot, and you might get pretty close for comfort to that maximum current capability. So yeah, so that's kind of a disappointment that these DRMOSs are just 40 amps. I was hoping they would be 60 amps because the GTX 680 SoC had 60 amp DRMOSs, 8 of them. So I was like, hey, maybe they just used the same VRM on this card, but no, they didn't. They swapped out to some cheaper ones, which is a bit disappointing, especially compared to the 770 Jetstream, which is on a GK104, which is a much smaller core, and that card has an 8-phase with FDMF 6823C, so you have a smaller core with a bigger, like better VRM than on this card, and this is the flagship card from Gigabyte, so it's a bit embarrassing to lose against a 770 from Palette, which, like, Palette is not even known to make that great of graphics cards. Like, sometimes they make some pretty nice ones, like the ones I'm mentioning here, but like they are not really known to be a big graphics card manufacturer that really does the best of the best. So yeah, but I mean, those power stages, like DRMOSs, like the DRMOSs, as far as I'm concerned, DRMOSs are power stages. They're just the most basic version of it because they, like the name says it, they have a driver, a high side and a low side, and then they have like a thing where they can raise like a thermal flag when they overheat. Whereas power stages have a lot more stuff like current sensing, short circuit protection, and like actual temperature sensing, not just hey, I'm overheating or hey, I'm not overheating. So yeah, like it's still fine. It's just that it could be better. We have other cards that are doing it better. So this is a bit of a letdown. But that's pretty much the only thing I have to complain about the VRM. If we look at the output filter, this is pretty sizable. We get a fair amount of 470 microfarad SMD polymer capacitors. We get 4 560 microfarads CAN types. I don't think they do much, but they're there. And yeah, like this, I think this is more capacitor. Like, I think this is better output filtering than you get on a reference card. Like, one thing that this does better than the palette cards I've mentioned before this, they only use CAN types as the output filter. And by using SMD polymers, Gigabyte might lose some overall capacitance because these are just 470 microfarads, whereas the CAN types you usually see used as output filters are 820 microfarads. But SMD polymer capacitors like these have a better electrical capabilities, like less ESR, less ESL, they just perform better. So you can get the same amount of filtering with less capacitance by just using a better capacitor. So I do like the capacitor choice they've made here. Though I have to say, the back is completely empty. You have this big strip of empty multi-layer ceramic solder points, which are even better for the electrical characteristics. They just have very, very little capacitance. You could populate that. Just Gigabyte chose that they wouldn't. And so yeah, there's no filtering on the back of the VRM, which I would have liked to see, like at least a little bit. But what they've done on the back, which is nice, is they have used 560 microfarad SMD polymers behind the core. On a reference card, you would get 330 microfarads. So yeah, they've basically used the same capacitor type, but they've put more capacitance directly behind the core, and they might have also used some capacitors with like better specifications, so like slightly better electrical characteristics, because there is differences even within the same type of capacitor. So they have put some nice capacitors directly behind the core. It's just that, yeah, having populated that strip would have been nice. It probably wouldn't have done anything, which is probably why it's empty. But just like, basically, I just like to have all the output filtering you can have. And this is just empty pads waiting to be populated. So this is capacitance you could have that you don't get. But it probably won't do anything. So yeah. Then for the memory VRM, we have a pretty standard two-phase. Over here it's controlled by this controller right here. That is a Richtech controller that has a code on it that you have to decode. I did try to read it off of this picture. I think it's saying DT equal. I did plug that into the Richtech controller markings PDF. Like that, there's a PDF. You can just Google like Richtech marking PDF. You should find it. That tells you the codes and tells you what IC this is. But what it told me it is like, it is a two-phase PWM controller, but it's telling me it can only output voltages between 2 and 5.5 volts, which, well, memory runs at 1.6 volts, at least for GDDR5. So I'm not sure if I'm pretty sure the chip it gave me was the wrong one. So I guess I read it wrong. Like I put the card back together before I checked what chip it actually is, so I only had the picture to check. So if you have the card in hand, just check physically what marking it has and then plug it into the datasheet. Yeah, as far as memory goes, like it's a pretty standard two-phase. That's like what you get on all the cards from this generation. Only thing that might be a bit annoying about it is just how far away it is from the actual memory chips, because the Vcore Vrm is taking up all the space. That means you are having more distance between your memory chip and your memory VRM, and therefore a longer power plane, which means there's more resistance, which means you're losing more voltage over that resistance in the power plane. You can pretty easily fix that by just outputting more voltage at the VRM, so that the memory chips are receiving the same amount of voltage. And I've seen that being done. It's not always done. So yeah, so like the memory chips are meant to get 1.6 volts, and you could fix the problem by just outputting 1.65 or 1.7 at the VRM, and then once your power reaches the memory chips, it's at the right voltage that's supposed to get. So yeah, not really a lot to say about the memory VRM. Like, it has some dual NFETs. Can't really read what they are. It's not really that, like, it's a memory VRM, it's not really that important. We do get two 560 microfarads SMD polymers as output filter, but that's pretty much everything we get. Well, I mean, there's these multi-layer ceramics in between there, but that's like all the output filtering we get. There is more here. That could be memory, and that could also be memory. But then on the back, yeah, I mean, there's nothing at the memory VRM, and then behind the memory chips we just get our pretty standard layout for 700 series. Like, you don't really get a lot of capacitors behind the memory chips, which means that if you mod them by adding more multi-layer ceramics, you could get a lot out of it. But they haven't really done anything special behind the memory chips. Like, sometimes you actually see cards that have an empty solder pad for like one of these capacitors. They are rarely ever populated, but having the pad is nice because then you can just add it on yourself. But yeah, they haven't done that here. Just your standard capacitor layout for behind the memory. Like, the back of the PCB is not really that exciting. that seems to be like a Gigabyte thing. They put all the stuff on the front of the PCB. Like my 2080 Ti, which is also a Gigabyte card, also just like the back is pretty much almost empty, and then everything is on the front. Yeah. Then we have over here our PEX or PLL rail. Basically, it's completely not important for overclocking on ambient. If you go sub-ambient, specifically liquid nitrogen, this becomes interesting because it can help fighting cold bugs. Like sometimes your card doesn't want to behave if you take it too cold, and changing the voltage on the PEX rail can help with that. So it's there. The little buck converter chip that it's generating is back here. But that's pretty much it. It's just there. Then we have our 3 power monitoring shunts. And over here is our INA 3221. So the INA 3221 is the chip that's doing the power measurements. And on 700 series, there is a lot of ways of removing your power limit. You could simply do a normal shunt mod by just putting a like 8 milliohm shunt on top of the existing 5 milliohm ones. Or you could do the more elegant way, because on this generation of cards you can mess with the power monitoring a lot more than it can on newer cards. Because what you can do is just straight up remove the INA 3221, or just remove these capacitors around it. That should just completely disable the power monitoring. It should just be gone after that. Like, it literally won't have a power limit anymore. Like, the power slider and MSI afterburner will disappear, the power measurements in GPU-Z will also disappear. If you remove that, the power limit is just gone. On newer cards, like this works on 600, 700 and 900 series. On 10 series and newer, removing the power monitoring chip will just make the card not work anymore. So I can't do that. What you can also do is just use Kepler BIOS tweaker. So you can just edit the GPU BIOS and give it like a 900 watt limit, and then you're also never going to hit your power limit again unless you do like liquid nitrogen, because then 780s and 780 Ti's become very, very power thirsty. So yeah, like, do whatever you want. Like, I think just modding the BIOS is the easiest way, because you don't need to solder anything. Just flash a 900 watt BIOS and then you're done. So yeah. And then we have another thing over here. That is a 10 amp fuse on our PCI Express slot 12 volt. So if there is a short circuit on the card that is connected to the 12 volt power plane of the PCI Express slot, this fuse will burn up and not burn your motherboard. Sadly, we are not getting any fuses on the 8 pins. So if something shorts there, well, I guess the card is just gonna catch on fire if your power supply is very cheap. If your power supply is good, it's gonna shut off immediately, and probably nothing will happen. You just shouldn't try to turn it on afterwards. Like, if you do that enough times, at some point, whatever is connected to the short circuit is gonna die. But yeah, I mean, fuses are nice to have. Like, at least you know your motherboard is protected if you blow the card up. But the card itself is like, I mean, I haven't checked, but I'm pretty sure the entire Vcore Vrm, or like 7 out of the 8 phases, are connected to the 8 pins. So if anything blows up, it's gonna be connected to your 8 pins. Go away, keyboard. So yeah, there won't be a fuse there. And are there any more things to talk about? The only thing I've noticed is this thing. It's not really important. That's just an LED connector. That's not used. That is used to like light up the green GeForce GTX logo on the reference card. I don't know why this card has it. It's just there, and I thought I would mention it. But yeah, like, your fan connector is down here. That's where your fan goes. That thing up there is just an LED connector. And yeah, I think that's pretty much it. So yeah, the PCB is decent, I would say. Like, it's okay. It's not the best one. Like, the 780 Ti Matrix has a much more powerful VRM. And the 780 Ti Classified, same thing. And then even the Jetstream and the Phantom, like Gainrod and Palette, use the same PCBs. So the 780 Ti Jetstream and the 780 Ti Phantom, they use the same PCB. They just come with different coolers from different like names like brands. Yeah, since that one has the better power stages, technically the PCB is a bit more capable, but I am not so sure about the output filter. Like, how much current your VRM can handle doesn't always mean that the more current it can handle, the better it will overclock. It's just like the sooner it will blow up if you have a less current capability. But the output filter on this card, even though it's not like super crazy, I think it is quite decent. And the Jetstream and Phantom cards, as I said, only have CAN-type capacitors. So as long as you're not maxing out the current capability of the VRM, I think that in terms of overclocking, this should be pretty decent. But like it's nowhere near the top end. Like it's okay, it's decent. Like I would go for this over a reference card. Surely, like I would basically go over everything that's not a reference card. So yeah, it's decent, but it's also not super interesting. It's just like, yeah, it's a custom card. Custom cards are usually better than reference, which this is, but I mean, I've said it 3 times so far. It's like nothing special. But I still like the PCB. And if I get the card repaired, just like I said, the memory modules have to be replaced. By the way, if you're wondering, pretty much all my Kepler-based cards are running on Hynix AFR, 2 gigabit AFR, so is this one. There's some exceptions. I have a 680 on MFR, I have my 780 Ti Matrix is using BFR, which is very, very good as it seems. But yeah, I pretty much only get Hynix. The only not Hynix card I have is the 770 Jetstream, which is on Samsung D-Die. But yeah, those are the memory chips I have. AFR seems to scale with voltage, at least on my 7970 Matrix, but I haven't tested on any NVIDIA card yet. So yeah. So I might run this card one day when I get those memory chips replaced. It's not gonna happen anytime soon because I've never replaced memory chips and I wanna pull it off successfully on a test card first because before I potentially ruin a 780 Ti, because this card actually has a decent core. Like, it's not the best, but it does pretty decently at stock. So yeah, but it's just like, it only worked for like 2 hours before the memory chip dropped in, because I heat gunned it and it came back to life for about 2 hours. But then the memory chips just started erroring out again, and heat gunning it another time didn't work. So those memory chips have to go. And I hope it's a memory chip, because there's a chance that the core itself is faulty, in which case the card is basically just done. Like, you're not fixing the core. Like, replacing the core, you might as well just get a different card. So yeah, you might see this running one day, but not soon. With that said, I have enough Kepler cards to deal with, so it's not really that this is such a big deal. It's just like, yeah, I would like to have this working. And with that, I think the video's done. We are already at 25 minutes. I was really hoping this would be shorter. So yeah, thank you all for watching. Hope you enjoyed, and until next time, goodbye.